There is something that has been traveling across space at speeds close to the speed of light for millions of years. Despite the fact that galaxies are often located millions of light-years distant from one another, gravity possesses the astonishing capacity to gather together clusters of hundreds to thousands of galaxies in close groupings. When complete galaxy clusters cluster together in such close proximity to one another, the enormous gravitational forces can cause them to get more and more entangled with one another until they are impossible to escape. This dance of gravitational forces frequently results in collisions that are extremely intense, which in turn creates stunning cosmic events. Galactic interactions have the potential to bring about the development of new stars, to disrupt the systems of stars that already exist, and even to bring about the merger of black holes. In the course of their exploration of the vastness of the universe, scientists have recently come across this phenomenon. Among all the galaxies in the universe, the Milky Way galaxy, which is the location of our solar system, is one of the most extensively researched. A description of the Milky Way's appearance from Earth is where the name Milky Way originates. When viewed from our vantage point, the Milky Way appears as a hazy strip of light that is visible in the night sky, where its individual stars appear to be indistinguishable to the human eye. Virgo supercluster is a large collection of galaxies that spans hundreds of millions of light-years and includes our galaxy as one of its members. Our galaxy is a part of the neighboring group of galaxies that collectively make up the Virgo supercluster. This particular group is one of the member clusters of the Lanaka supercluster, which contributes to the complexity and magnitude of our cosmic neighborhood thanks to its inclusion. According to a number of astronomers, the Milky Way galaxy is joined by a number of other galaxies. Estimates show that the Milky Way galaxy includes anywhere from 100 billion to 400 billion stars, in addition to at least an equivalent number of planets. The Milky Way is a galaxy that contains a large range of celestial bodies, ranging from gas giants to rocky planets and everything in between. The sheer grandeur of the Milky Way is an incredible thing to behold. Approximately 27,000 light-years away from the center of the galaxy, our solar system is located on the inner edge of the Orion Arm, which is a spiral-shaped concentration of gas and dust. This is where our solar system can be found. Sagittarius A* is a supermassive black hole that is thought to have a mass that is around 4.1 million times that of our Sun. It is a radio emitter that is extremely powerful and is located at the center of our galaxy. The surrounding stars and gas, which circle around this enormous gravitational well at amazing velocities of around 220 kilometers per second, are subject to a significant influence as a result of this gravitational well. Scientists have been fascinated by the dynamics of these orbits for a very long time. They believe that the constant rotational speed that has been observed is in contradiction with the classical Newtonian physics. This has led them to the conclusion that a significant portion of the mass of the Milky Way is not visible to traditional telescopes. Dark matter is a mystery substance that does not emit or absorb electromagnetic radiation, but it is vital for explaining the gravitational effects that are observed in galaxies. This mass that cannot be seen is referred to as dark matter. When viewed through the lens of neighboring galaxies, the incredible speed at which the Milky Way as a whole is traveling is estimated to be roughly 600 kilometers per second. The Milky Way is placed into the greater framework of the universe as a result of its rapid migration across the cosmos, which highlights the dynamic nature for which it is known. Furthermore, the most ancient stars in the Milky Way are almost as old as the universe itself. Recent discoveries have suggested that these stars most likely formed not too long after the monumental event that is commonly referred to as the Big Bang. Among the two largest galaxies that are part of the Local Group, which also includes the Andromeda Galaxy, it is believed that the Milky Way is one of the members. According to some estimates, the mass of the Milky Way is anywhere between 890 billion and 1,540 billion times that of the Sun. This makes it a formidable gravitational giant in the nearby cosmic terrain. Through the application of cutting-edge equipment, researchers have uncovered a considerable quantity of activity taking place within this space-time galaxy. There are around 10 billion white dwarfs, 1 billion neutron stars, and over 100 million stellar black holes dispersed across its immense expanse. This is in addition to the hundreds of billions of stars and planets that are already present. The space between the stars is filled with a disk of gas that is referred to as the interstellar medium. This medium acts as a reservoir of ingredients that can be used for the development of new stars. Significant events, on the other hand, can potentially take place outside of the Milky Way. In point of fact, scientists have lately discovered something that is quite unsettling, roughly 730 million light-years distant from the planet Earth. Since the beginning of time, astronomers have been fascinated by big explosions and collisions. They are constantly competing with one another to find cosmic occurrences that are both larger and brighter overall. In February of 2022, a groundbreaking study was published in the Journal of Astronomy and Astrophysics. The study presented one of the most detailed photographs of a gigantic shock wave that has ever been obtained. Abell 3667 is a fascinating galaxy cluster that is made up of two groups of galaxies colliding with one another. This collision is an occurrence that is awe-inspiring and a monument to the forces that are at work in the universe. In the vicinity of Abell 3667, there are around 550 distinct galaxies that are gradually combining into a massive cosmic soup. The interactions between these galaxies are generating an environment that is both active and complicated. Scientists have determined that the tremendous shock wave that they have observed is the result of the merging of these two galaxy clusters. Despite the fact that this cosmic collision is not easily visible to the majority of telescopes at the moment, it has generated a significant disruption wave in the vicinity, which has led specialists to describe it as a massive shock wave erupting from both ends of the merging cluster. Due to the fact that this shock wave can only be observed at radio wavelengths, it offers astronomers a one-of-a-kind opportunity to gain insight into the chaotic processes that are underway throughout the cosmos. The Meerkat Radio Telescope Array was deployed by researchers in South Africa in order to visualize the radio relics of both sections of the shock wave. As a result of this groundbreaking research, it was discovered that the structures of the shock wave are substantially more detailed than was previously thought, thereby exposing a complex interaction of forces that are acting. Similar to the gas that can be found within galaxies, the temperature ranges that are contained within this shock wave are extremely diverse, ranging from 10,000 to 1 billion Kelvin. The theory that the MV cloud, which is a large gas cloud, was ripped from a galaxy during the collision has been significantly strengthened as a result of this observation. Dr. Ming went on to reveal that this cloud was found in the galaxy cluster Abell 1367, which is also referred to as Leo. This cluster is comprised of roughly 70 galaxies and is situated approximately 300 million light-years away from Earth. The scientists were keen to find out why the gas clouds had not dispersed despite the fact that they had departed their galaxy such a long time ago. According to their estimations, a magnetic field has the ability to preserve the integrity of the gas cloud against instabilities for a considerable amount of time. On the basis of the mass of this cloud, it is plausible to assume that the galaxy from which it split was also of a very large size. It is the aim of the research team that this cloud will be of assistance to them in the future when they are searching for the parent galaxy of the galaxy. This cloud will provide them with priceless insights into the processes of galaxy creation and evolution. Furthermore, this knowledge will assist scientists in identifying clouds that are comparable to those seen in other parts of space. The information that was acquired through observations lends support to the concept that the intracluster medium has the ability to strip galaxies of their gas. This process has profound consequences for our understanding of the development of galaxies. Scientists are able to get a peek of what the universe looked like when it was young, which provides them with tantalizing clues about the birth and evolution of galaxies. These discoveries, along with others, give them this view. On the other hand, the ongoing disclosure of secrets from space is also a source of dread since it highlights the fact that we have a limited understanding of the immense world that encompasses us. As we gain more knowledge, we are confronted with an increasing number of questions, which highlights the importance of continuing to investigate and study the universe. In the process of gazing into the depths of space, we are reminded of the complex and ever-changing nature of the cosmos, which serves as a reminder of our position within this vast cosmic tapestry. The comments section below is where you should share your thoughts with us.